I mentioned that we were going to be doing proofs, and what I meant by that was kind of like in geometry when you used to do geometric proofs and you used to have to cite a reason for what you were saying. So you might say, by definition of parallel lines, or by side angle side, and that kind of thing. You had to provide a justification for each of your steps. So we're going to do that here. We're going to find the limit of this quantity as x approaches -5, and we're going to justify each step. I like to think of this as if I were an attorney in court, and we say we're going to do something, and the opposing attorney says, "What right do you have?" And then we cite the law. Well, I'll tell you what right I have. The quotient property tells me I can do that. So we're going to cite steps for finding the limit of this, and then we'll see how this plays back in with the whole direct substitution thing. So we want to find this limit and cite a reference for each step. So we're just going to kind of very non-technically refer to different properties here. So we're only going to do things that these properties allow us to do, not what we think is okay, what the properties say we can do. All right, so scroll up a little here. We have the limit of -x squared minus 9x plus 1 as x approaches -5. And we would like to find a final answer, like a numerical answer to this. Well, I noticed that here I have a series of terms being added and subtracted. The sum or difference property says that I'm able to separate those. So let's let that be our first step. So I would have the limit as x approaches -5 of -x squared minus the limit as x approaches -5 of 9x plus the limit as x approaches -5 of 1. Okay? And then the step I'm going to say, what's my reference? I'm going to say the sum or difference property. Okay? So justify. Next, I can only use things. I don't have a specific thing for -x squared. I have x squared. That would fit this one, but I don't have -x squared. So let me hold on to that. Here I've got 9x. I've got x, but I don't really have anything for 9x. So let's think about the limit of 1 as x approaches -5. Do we have something that tells us, oh yeah, we can find this limit? Absolutely we do. We have this property here that says the limit of a constant as x approaches any value, as long as it's a real number, is equal to that constant. So, I might picture the line y equals 1, and at x equals -5, of course, the y value would be -1. This result is 1. So that's the only thing I'm going to work out for right now. So you can combine steps, but I'm not going to in this one since it's our kind of an introductory problem for us. Kind of wrote that backwards. So I'm going to cite the property that says that, and I'm just going to call it limit of a constant. Okay. These don't have official names like in geometry, so we just want to kind of reference the essence, if you will, of the different properties. Okay? Well, these kind of have names, but these not so much. Moving on. Well, I've got to deal with these two things because they are close to matching up with these two, but not quite. What they both have going on is a multiplier, a coefficient, if you will, a scalar multiple, okay? So I will use the property, the scalar multiple property, and simplify or rewrite that, I should say. This has a scalar multiple of -1, so that's -1 times the limit of x squared as x approaches -5. This has a scalar multiple of 9, so I have 9 times the limit of x as x approaches -5, and then I've already got my 1 out here. Okay? Well, I need to cite a property, and that is my scalar multiple property. Okay. We are getting close. Now, finally, at this point, I have x to some power. X to some power says that I can direct substitute in that c, and I have -1 times -5 squared. Now, I'm going to do two things in this step, so I'm going to cite this property down there. This is, I'm just going to actually write the property out, to tell you the truth. I can't really think of a great way to say that. I don't want to say power, because that kind of refers to this back here, which would work, but I'll just write down the actual property itself. Minus 9 times, I have a property back here that says the limit as x approaches c of x is equal to c. So the limit as x approaches -5 of x would be equal to -5. And again, I'll just write that property down here as my justification. And then I'm just bringing my 1 down. I had already cited that. And finally, it's just work it out. So -5 squared is 25 times -1 is -25. -9 times -5 is 45. And then plus 1 for a grand total of 20 plus 1 is 21. Okay. So there we have working this out and citing each step. If you do any exploration on Maple, you'll see the ability to work out some limits and you cite different properties. So this is good practice for that.